Visual direction. The screen is filled with a deep velvet blackness, sprinkled with the faint, static dust of distant stars. The camera moves imperceptibly slow, drifting through the void. The soundscape is a low, resonant drone, like the vibration of the universe itself, layered with the soft, rhythmic breathing of a sleeper. Tonight, we begin a journey that takes us beyond the familiar boundaries of our home. We are going to leave the blue skies of Earth behind. We are going to drift past the silent, cratered face of the Moon and float beyond the orbits of Mars and Jupiter. We are going to leave the warmth of our sun, watching it fade from a blinding sphere of fire into just another bright star in a sea of diamonds. We are traveling out into the deep dark. But we are not stopping at the edge of our solar system. We are not even stopping at the edge of our galaxy, the Milky Way. Our destination lies across a chasm so wide and so deep that the human mind struggles to comprehend its scale. We are looking toward the other islands of light in the cosmos. We are looking toward other galaxies. For as long as humanity has had eyes to see, we have looked up. We have traced shapes in the constellations and wondered what lies in the spaces between them. We have built telescopes that act as time machines, peering back into the ancient history of the universe. We have learned that we live on a spiral arm of a vast galaxy, a swirling city of stars containing hundreds of billions of suns. But we have also learned something else, something profound and somewhat lonely. We have learned that we are, in a sense, stranded. Imagine standing on the shore of an infinite ocean. You can see other islands on the horizon, glowing faintly in the mist. You know they are there. You know they are real. But the water between you and them is so vast, and the boat you have is so small, that reaching them seems impossible. This is the reality of our position in the universe. The distances between stars are enormous, but the distances between galaxies are a silence so profound, it swallows sound, light, and time. To understand why we need a new theory, a new way of moving, we must first sit with the reality of distance. We must feel the weight of it. Consider the speed of light. It is the fastest thing we know. In 1 second, a beam of light can travel around the Earth 7.5 times. It is a speed so fast that, to us, it appears instantaneous. When you flip a switch, the room floods with illumination without a pause. But on the cosmic scale, light is slow. It is agonizingly slow. If you were to board a vessel traveling at the speed of light, it would take you over 4 years just to reach our nearest stellar neighbor, Proxima Centauri. 4 years of silence, 4 years of staring into the void. And that is just the house next door. If you wanted to cross our own galaxy, the Milky Way, from one edge to the other, traveling at this ultimate speed limit, it would take you 100,000 years. 100,000 years. That is longer than recorded human history. Civilization would rise and fall, ice ages would come and go, and you would still be crossing the same galaxy. But even that vast distance is nothing compared to the gulf between galaxies. Look toward the constellation of Andromeda. There, a faint smudge of light hangs in the darkness. It is the Andromeda Galaxy, our nearest large neighbor. It is a spiral city much like our own, teeming with stars and planets and, perhaps, other eyes looking back at us. To reach it, traveling at the speed of light, would take 2.5 million years. 2.5 million years. Before humans walked upright, the light we see from Andromeda tonight began its journey. If we were to send a signal, a message of hello, it would travel through the emptiness for eons. By the time it arrived, the species that sent it might no longer exist. This is the prison of distance. The universe is expanding, and the space between galaxies is stretching. The further away a galaxy is, the faster it is moving away from us. There are galaxies we can see in our telescopes today that we will never be able to reach, no matter how long we travel, because the space between us is growing faster than we can move. We are seemingly locked in our local group of galaxies. We are castaways on a beautiful, lonely island. For decades, this realization has haunted physicists and dreamers alike. It suggests that we are destined to be alone, It suggests that no matter how advanced our technology becomes, no matter how powerful our rockets, we will never cross the void. The speed limit of the universe, the speed of light, is a wall we cannot break. Conventional physics tells us that as an object with mass approaches the speed of light, it requires more and more energy to accelerate. To reach the speed of light exactly would require infinite energy. It is a mathematical impossibility. We can approach the barrier, but we can never pass it. And so we drift. We drift on our pale blue dot, circling a yellow star, rotating in a spiral arm, drifting through the dark. We look at the lights on the horizon, and we accept that they are out of reach. We accept that the stars are for looking, not for touching, but the human mind is restless. It does not accept walls easily. When faced with an impossible barrier, we do not simply turn back. We look for a door, we look for a loophole, we look for a way to change the rules of the game. What if the barrier of light speed is not the final word? What if the problem is not how fast we move, but how we understand motion itself? In the quiet corners of theoretical physics, in the scribbled notes of mathematicians and the complex equations of general relativity, a possibility has emerged, a theory. It is a whisper of a possibility, but a possibility nonetheless. It suggests that we have been looking at the problem the wrong way. We have been trying to run faster across the track, when perhaps we should be thinking about moving the track itself. This theory offers a different vision of the future. A future where the millions of years of travel time dissolve. A future where the gulf between galaxies can be bridged. A future where humanity is not just a watcher of the skies, but a traveler within them. As we drift here, in the hypothetical silence of deep space, let us clear our minds of rockets and fire. Let us forget about engines that push and shove against the void. Let us imagine a different kind of movement, a movement that is more like surfing than running. A movement that is quiet, elegant, and profoundly transformative. The void is vast, yes. The silence is deep. But the fabric of the universe is not as rigid as it seems. It is flexible. It is malleable. And if we can learn to touch it, to shape it, to bend it, then the stars are not so far away after all. Let us breathe in the stillness. Let us watch the slow, majestic rotation of the galaxies. And let us prepare to look deeper into the fabric of reality, to find the secret that might one day set us free. To understand how we might reach the stars, we must first change how we perceive the stage upon which the universe performs. We tend to think of space as nothingness. We think of it as an empty box, a vacuum, a mere absence where objects exist. In this view, space is passive. It is just the distance between things. But in the early 20th century, a patent clerk named Albert Einstein changed everything. He asked us to look closer at the nothingness. He showed us that space is not empty and time is not constant. Instead, they are woven together into a single, dynamic fabric called space-time. Imagine a large, heavy sheet stretched out tight. This is space-time. If you place a bowling ball in the center of that sheet, it curves. It dips. The fabric bends around the weight of the ball. This curvature is what we experience as gravity. When Earth orbits the Sun, it is not being pulled by an invisible tether. It is rolling along the curvature of the space-time fabric created by the Sun's mass. It is following the path of least resistance along a curved surface. This was the great revelation of general relativity. Matter tells space how to curve, and space tells matter how to move. But there is a second, quieter implication in Einstein's work, one that took decades for us to fully appreciate in the context of travel. If space is a fabric, if it can curve and bend and stretch, then space itself is dynamic. It is not a fixed stage, it is active. This leads us to the crucial loophole. The speed of light is the universal speed limit for anything traveling through space. You, me, a rocket ship, a photon, we are all bound by this limit. We cannot move through the fabric faster than light. However, the fabric itself has no such limit. Space can expand, contract, and twist at any speed it chooses. We know this because it has happened before. In the very first moments after the Big Bang, during the epoch known as inflation, the universe itself expanded faster than the speed of light. It didn't break the laws of physics because no information was traveling through space. Space itself was simply getting bigger. It is like a conveyor belt. If you walk on a conveyor belt, you have a maximum walking speed. But if the conveyor belt moves, you move with it, potentially much faster than you could ever walk alone. For almost a century, this idea remained a quirk of cosmology, a description of the distant past. But in 1994, a Mexican theoretical physicist named Miguel Alcubierre was watching a science fiction television show. He watched as a starship engaged its warp drive, vanishing into the stars in a streak of light. Most of us would watch that and see only fantasy. But Alcubierre looked at it with the eyes of a physicist. He wondered, is there a solution within Einstein's general relativity that would allow for this? Not by breaking the laws of physics, but by using the flexibility of space-time itself. He sat down and began to do the math. He looked for a metric, a geometric description of space that would allow a localized volume of space-time to move. What he found was a valid solution to Einstein's field equations. It is now known as the Alcubierre drive. Here is the concept, visualized in our calm, meditative theater of the mind. Imagine a spacecraft floating in the deep black. It is not firing rockets. It is not burning fuel to push itself forward. Instead, it is encased in a ring, a torus of exotic machinery. When the drive is activated, it does not push the ship. Instead, it manipulates the space-time fabric directly in front of the ship and directly behind it. The device contracts the space in front of the vessel. It bunches the fabric up, pulling the destination closer. At the same time, it expands the space behind the vessel, pushing the departure point away. Picture a surfer on a wave. The surfer is not paddling. The surfer is essentially stationary relative to the board, but the water itself is rising and moving, carrying the surfer forward. In the Alcubierre metric, the ship sits inside a warp bubble. Inside this bubble, space-time is flat and normal. The travelers inside would feel no acceleration. They would not be pinned to their seats by G-forces. They could sip a cup of tea without it spilling. Their local reality is calm. But outside the bubble, the universe is being aggressively manipulated. The ship is surfing a wave of space-time. Because the ship is not moving through space, because it is carrying a pocket of space with it, the speed of light barrier does not apply in the traditional sense. The bubble itself pushes through the cosmos. The ship inside is stationary relative to its immediate surroundings. This means that, theoretically, the bubble could travel at 10 times the speed of light, or 100 times, or 1,000. The journey to Proxima Centauri, which takes light 4 years, could be done in months or weeks. The journey to Andromeda, that distant spiral currently 2 million years away, could theoretically be achieved within a human lifetime. This theory changes the map of the universe. It turns the impossible ocean into a navigable sea. It transforms the galaxies from distant, unreachable paintings into destinations. It is a beautiful, elegant thought. A ship wrapped in a cocoon of space-time, slipping through the universe without ever breaking the speed limit, because the road itself is moving the car. But as with all things in theoretical physics, the leap from a mathematical equation to a physical reality is enormous. The math works. Einstein's equations allow it. But the requirements to build such a machine are staggering. As we drift here, contemplating this bubble of speed, we must confront the cost. We must look at what is required to bend the fabric of reality so drastically. We must look at the energy. To bend space, you need mass and energy. The Earth bends space a little bit, which keeps our feet on the ground. The Sun bends space a lot, which keeps the planets in orbit. To compress space in front of a ship and expand it behind, we would need a density of energy that is difficult to comprehend. And we would need something even stranger. We would need a form of energy that acts in reverse. Gravity, as we know it, is attractive. Mass pulls things together. It curves space downward, like the bowling ball on the sheet. But to make the Alcubierre drive work, we need to expand space behind the ship. We need an anti-gravity effect. We need the sheet to push upward. This requires something called negative energy, or negative mass. It sounds like science fiction. In our daily lives, we only see positive mass. An apple has positive mass. A rock, a planet, a star. All positive. Energy too is positive. But quantum mechanics, the physics of the very small, hints that negative energy is not strictly impossible. We see fleeting glimpses of it in something called the Casimir effect, where two metal plates are placed so close together that the space between them has a lower energy density than the vacuum outside, essentially a form of negative energy. But the amount needed for a warp bubble is immense. Early calculations suggested we would need more energy than exists in the entire observable universe just to move a small ship. However, hope is a persistent thing. Over the years, physicists have returned to Alcubierre's equations. They have refined them. They have optimized the shape of the bubble. They have found ways to reduce the energy requirements. Recent calculations suggest the energy required might not be the mass of the universe, but perhaps the mass of a planet. Or maybe, with the right geometry, the mass of a large asteroid. Still enormous, yes, but no longer infinite, no longer strictly impossible. So we float here, suspended between the math and the engineering. We have the theory, we have the map, we know that the fabric of reality is willing to bend if we can find the strength to press against it. The Alcubierre drive represents the ultimate triumph of mind over matter. It is the realization that we do not have to accept the universe as a rigid cage. It suggests that with enough understanding, we can reshape the bars of the cage into a vehicle. But let us pause. Let us not rush to the engines just yet. The idea of warping space is the most famous path to the stars, but it is not the only shadow in the math. There are other theories, other strange corridors in the library of physics that might lead us to the same destination. As we drift through this imaginary void, let us turn our gaze to another possibility. A possibility that doesn't involve moving across the surface of the fabric, but rather punching a hole through it. We must speak of bridges. We must speak of shortcuts. We must speak of the tunnels that might link the beginning to the end instantly, for the universe is not just a sheet, it can be folded. And if it can be folded, then the longest distance between 2 points is no longer a straight line. Stay with this calmness. Let the concept of the warp bubble fade gently into the background, like a dream upon waking. The ship is still there, floating. But now, we look for a door in the darkness. We are preparing to enter the realm of the wormhole. Visual direction. The warp bubble from the previous scene gently dissipates, leaving the camera floating once again in the stillness of deep space. The view slowly pans toward a massive rotating black hole, its accretion disk glowing softly in amber and gold, swirling like heavy cream in coffee. We have spoken of surfing the waves of space-time, of bending the fabric to move faster than light without actually moving. It is a concept of travel that relies on speed. But there is another way to think about crossing the void, a way that relies not on speed, but on geometry. Imagine for a moment that you are an ant walking on a large sheet of paper. You are on one edge of the paper and you want to reach the other side. To you, the paper is flat and vast. The journey is long. You have to walk every inch of the distance. But now, imagine that someone picks up the paper and gently folds it in half. They bring the two edges together until they touch. Suddenly, for the ant, the distance is gone. You can simply step from one edge to the other. The journey that would have taken a lifetime now takes a single step. This is the essence of the wormhole. In the language of physics, it is known as an Einstein-Rosen bridge. Named after Albert Einstein and his colleague Nathan Rosen, who in 1935 discovered a curious mathematical possibility hiding inside the equations of general relativity. They found that the fabric of space-time, which we know can curve and bend, might also be able to connect to itself. They found that a massive object, like a black hole, creates such a deep well in the fabric of space that it might, theoretically, funnel down into a tunnel. And if that tunnel were to connect to another point in space, perhaps a point millions of light years away, it would form a bridge, a shortcut through the dark. Visualizing this is difficult for the human mind, which is built to understand 3 dimensions. We see space as length, width, and height. But a wormhole exists in the 4th dimension. If you were floating in space, approaching a wormhole, you would not see a tunnel, you would not see a door, you would see a sphere. It would be a sphere of perfect distortion, like a crystal ball floating in the void. But instead of showing you a reflection of yourself, it would show you the stars on the other side. It would be a window into another galaxy, spherical and shimmering, hanging there against the background of the Milky Way. If you were to drift into this sphere, you would not hit a surface. You would simply slip through. You would pass through the throat of the wormhole. Inside, the view would be unlike anything in human experience. The light from the universe you just left would be visible behind you, and the light from the destination would be visible ahead of you. But in the middle, in the throat itself, space might appear twisted, a kaleidoscope of passing star systems and bent light. And then, just as quietly as you entered, you would emerge. You would float out of the sphere on the other side. The stars would be different. The constellations would be unrecognizable. You might be in the Andromeda Galaxy, you might be in the Virgo cluster, you might be on the other side of the observable universe, and the journey would have taken moments. This is the dream of the wormhole. It is the ultimate answer to the intergalactic problem. It deletes distance. It makes the size of the universe irrelevant. But, like the Alcubierre Drive, the Einstein-Rosen bridge comes with a heavy price. It comes with a fragility. The early calculations showed that these bridges are incredibly unstable. The moment a wormhole forms, gravity tries to slam it shut. The throat pinches off faster than light can travel through it. If you tried to enter, the bridge would collapse, crushing you into a singularity. It would be a door that slams the instant you touch the handle. To keep the door open, to make the wormhole traversable, we need a prop. We need something to push against the crushing weight of gravity. And here we return to that strange elusive ghost of physics, exotic matter. Just as the warp drive needs negative energy to expand space behind the ship, a wormhole needs negative energy to thread the throat. It acts as a repulsive force. It pushes the walls of the tunnel outward, fighting against gravity, holding the bridge open long enough for a traveler to pass. Imagine a tunnel through a mountain of sand. Without support, the sand collapses instantly. But if you line the tunnel with a strong, rigid tube, the sand is held back. Negative energy is that tube. We do not yet know if we can mine or manufacture enough negative energy to build such a tube. We do not know if the universe allows for such structures to exist on a large scale. But let us imagine that it does. Let us drift into a future where this engineering is possible. In this future, humanity, or perhaps our descendants, would not need faster than light ships. We would not need to spend generations in cryosleep. Instead, we would become builders of gates. We might tow the mouth of a wormhole to the edge of our solar system, placing it in a stable orbit around Neptune or Pluto. It would sit there, a silent sentinel, a spherical mirror reflecting a distant sun. To travel to another galaxy would simply be a matter of transit. A shuttle would depart Earth, fly to the gate, and slip through. In an afternoon, you could walk on a planet orbiting a star in the Triangulum Galaxy. The network of galaxies would become a subway map. The vast, terrifying voids between them would be bypassed entirely. The isolation of the human experience would end. The universe would still be vast, yes, but it would no longer be disconnected. However, building these bridges requires more than just clever math. It requires power. It requires a mastery over the physical world that is so far beyond our current capabilities, it borders on the divine. To punch a hole in reality, or to bend it into a wave, requires energy on a scale that makes our nuclear power plants look like flickering candles. This brings us to the next chapter of our journey. We must look away from the theoretical physics and look toward the practical reality of energy. We must ask, who could possibly build these things? And are we, the people of Earth, even capable of dreaming of such power? As we float here in the quiet dark, let us look back at our own history of energy. When our ancestors first huddled in caves, their energy source was fire. a chemical reaction. Burning wood to create heat and light. It was small, intimate, and limited. Then we learned to harness the wind and the water. We built mills, we sailed ships, we tapped into the kinetic energy of the planet. Later, we unlocked the energy stored deep within the earth, coal and oil. We burned the fossilized sunlight of ancient forests to build cities and drive machines. And finally, in the last century, we learned to split the atom. We touched the fundamental power that binds matter together. But even with nuclear power, we are, on a cosmic scale, barely awake. In 1964, the Soviet astronomer named Nikolai Kardashev proposed a scale, a way to measure the advancement of a civilization based purely on how much energy it can harness. It is a ladder of progress, and looking at it helps us understand what it will take to reach the galaxies. At the bottom of the ladder is a Type 1 civilization. A Type 1 civilization has mastered its home planet. It can harness all the energy that falls on its world from its parent star. It controls the weather. It mines the crust in the oceans. It captures every photon of sunlight. We, humanity, are not yet a Type 1 civilization. We are close, perhaps. Physicists estimate we are a Type 0. 7. We are still burning dead plants. We are still at the mercy of our climate. We are still struggling to manage the resources of one single world. To build a warp drive, or to open a wormhole, we would likely need to be far beyond Type 1. We would need to ascend to Type 2. A Type 2 civilization has mastered its star. Imagine a civilization that does not just put solar panels on a roof, but put solar panels around the sun itself. This is the concept of the Dyson sphere. A massive shell, or a swarm of millions of satellites completely surrounding a star, capturing 100% of its energy output. The energy of a star is incomprehensible. In 1 second, the sun produces more energy than humanity has used in its entire history. A Type 2 civilization has access to this power on tap. With the energy of a star, you can do more than just light up cities. You can power a laser strong enough to push a light sail to other stars. You can generate the antimatter needed for high-efficiency engines. You might even begin to experiment with warping small pockets of space-time. But even a Type 2 civilization might find intergalactic travel difficult. The energy required to cross the void between galaxies, to bridge the millions of light-years, might demand the resources of something even greater. It demands a Type 3 civilization. A Type 3 civilization has mastered its galaxy. They do not just harvest one star, they harvest billions. They span the entire Milky Way. They have colonized every habitable system. They draw power from black holes. They manipulate the rotation of pulsars. They are the gardeners of the galaxy. To a Type 3 civilization, the galaxy is not a wilderness, it is a home. And the intergalactic void is not a barrier, it is just the next ocean to cross. It is likely that only a civilization of this magnitude possesses the engineering capacity to build stable, large-scale wormholes. They would be the ones to construct the highway system of the universe. When we look up at the night sky, we see silence. We see no obvious signs of these galactic empires. This is known as the Fermi paradox. If they exist, where are they? Perhaps they are there, but their engineering is so advanced, it looks like nature to us. Perhaps the stars that act strangely, or the black holes that hum with unusual radiation, are not natural phenomena, but the exhaust vents of their engines. Or perhaps they are simply waiting for us to grow up. To reach the galaxies, we must first survive our own adolescence. We must survive the transition from Type 0 to Type 1. We must learn to live on our planet without destroying it. Then, we must learn to leave it. The journey to other galaxies is not just a journey through space, it is a journey through time and maturity. The theory of the warp drive and the wormhole gives us a destination, but it does not build the ship. We must build the ship. And the building will take time, not years or centuries, but millennia. It requires a new kind of thinking. We are used to thinking in terms of election cycles, fiscal quarters, or human lifetimes. But the project of reaching the galaxies is an intergenerational project. It is a cathedral that takes 10,000 years to build. The people who lay the foundation stones will not see the spire. The people who design the first warp-drive prototypes will not be the ones to see the Andromeda Galaxy up close. We must learn to be comfortable with this. We must learn to find meaning in being the ancestors of the travelers. We are the ones who look at the map and say, it is possible. We are the ones who begin the work, knowing we will not finish it. There is a profound beauty in that. It connects us to the future. It connects us to the children. Of the children of our distant descendants, who will one day stand on the bridge of a starship, watching the Milky Way recede into a spiral of light behind them. They will know that they are there because we dared to dream it was possible, because we looked at the equations and saw a path. As we drift deeper into this reverie, let us consider the destination again. Why go? Why cross the void? Is it just curiosity? Is it just the need to expand? Or is it something deeper? The universe is expanding. The galaxies are moving apart. In the far, far future, billions of years from now, the other galaxies will have moved so far away that their light will no longer reach us. The sky beyond our galaxy will be truly, permanently black. If we stay here, we will eventually be alone. Truly alone. The drive to reach other galaxies is a drive against the dying of the light. It is a refusal to let the universe drift apart. It is a desire to weave the cosmos back together, to connect the islands before they drift into the eternal mist. It is the ultimate act of connection. And now, as we contemplate the scale of this ambition, let us turn our minds to the journey itself. Let us imagine that the engines are built, the wormholes are open, the energy is harvested. What would it be like to leave the Milky Way? What would it look like to float in the true void, halfway between home and the unknown? Let us drift out of the galaxy now. Let us rise above the spiral arms. Let us look down at our home from the outside and prepare for the final leg of our journey into the deep unknown. Visual direction. The camera pulls back from the rotating black hole of part 4. It rises up higher and higher until the black hole is a speck. Then the camera accelerates backwards. Stars streak past, thousands, millions of them. We see the great spiral arms of the Milky Way recede until the entire galaxy is visible, a majestic glowing pinwheel suspended in absolute darkness. We have spent our entire existence inside a crowded room. The night sky of Earth is a ceiling painted with neighbors. Every star you see with your naked eye, every constellation you have ever traced, belongs to our local spiral arm. We are surrounded by light. But now, imagine that the ship, the vessel built by a civilization of the far future, has reached the edge. It has passed the outer rim of the Milky Way. It has navigated through the halo of old red stars that guard the galaxy's perimeter. And now, it pushes out into the deep. As we leave the galaxy behind, the view changes. For the first time, the sky is not full. Behind us, the Milky Way hangs like a spilled islands of diamonds. It takes up half the sky, a breathtaking, swirling storm of light. We can see the dense yellow glow of the galactic core. We can see the dark lanes of dust where new stars are being born. It is beautiful. It is home. But if we turn the ship around, if we look forward, there is almost nothing. This is the intergalactic medium. It is the truest silence in existence. Inside a galaxy, there is about 1 atom of hydrogen for every cubic centimeter of space. It is a vacuum, but it is a crowded vacuum. Out here, between the galaxies, there might be 1 atom per cubic meter. It is a void so pure that sound is a memory that never existed. As we drift further, the Milky Way begins to shrink. It goes from filling the sky to being a large object like a moon. Then it becomes a bright coin. Finally, it becomes just another smudge in the dark, indistinguishable from the other distant galaxies. Here, in the deep void, we are truly alone. There are no nearby stars to warm us. There are no planets to land on. There is only the ship and the crew and the hum of the drive bending space around us. The psychology of this journey is as daunting as the physics. On Earth, we are defined by our surroundings. We are defined by the horizon, the ground, the sky. Here, there is no horizon. There is no up or down. There is only the endless, velvet black, punctuated by faint, fuzzy patches of light that are millions of years away. A traveler on this journey would need a mind of steel. They would need to find comfort in the emptiness. They would need to understand that they are a microscopic spark carrying the fire of consciousness through a cathedral of night. But there is a beauty here too, a cold, stark, geometric beauty. Without the interference of dust and gas, the view of the universe is crystal clear. You can see the structure of the cosmos. You can see the cosmic web. Galaxies are not scattered randomly. They are strung together like pearls on invisible filaments of dark matter. They form great walls and clusters surrounding colossal voids where nothing exists at all. From the bridge of our ship, we can see the architecture of reality. We can see the Great Attractor, a gravitational anomaly pulling thousands of galaxies towards it. We can see the Virgo cluster, a massive city of galaxies, glowing with the combined light of trillions of stars. We are no longer citizens of a planet. We are not even citizens of a galaxy. We have become citizens of the universe. And as we travel, using our warp drive to compress the millions of light years into manageable months, we realize something profound. We realize that the emptiness is not a barrier. It is a canvas. The distance between galaxies is not there to keep us apart. It is there to give the universe scale. It is there to allow each galaxy to evolve its own unique story, its own chemistry, its own life. We are traveling from one story to another. We are the cross-pollinators of the cosmos. Imagine arriving at a new galaxy. Imagine the moment the ship slows down. The warp bubble dissolves. The stars of a new spiral arm fill the view screen. These are alien stars. The planets circling them have different chemical compositions. The life that might exist there has followed a different evolutionary path, untouched by the history of the Milky Way. To reach this place is to reset the clock of discovery. It is to begin the age of exploration all over again, on a scale that is infinite. We have crossed the ocean. We have found the new world. And we realize that there are billions of new worlds waiting for us. Our journey is coming to an end. We have traveled from the surface of Earth, past the planets, beyond the sun, out of the galaxy, and across the great void. We have used the laws of physics, general relativity, quantum mechanics, the curvature of space-time, to turn a dream into a destination. But as we drift here, in the light of a foreign galaxy, we must return to the present. We must return to the reality of here and now. Today we do not have a warp drive. We do not have a wormhole generator. We do not have the energy of a star, let alone a galaxy. We are still standing on the shore, getting our feet wet. We are still arguing about resources. We are still looking up at the moon and finding it difficult to go back. So, what is the point? Why dream of reaching other galaxies when we have so much work to do here? The point is the horizon. A species without a horizon is a species that looks inward. It is a species that fights over scraps. It is a species that stagnates. The theory, the Alcubierre drive, the wormhole, the physics of the impossible, gives us a horizon that is effectively infinite. It tells us that there is no end to our potential. It tells us that the laws of the universe do not forbid us from leaving. They only demand that we grow smart enough and wise enough to figure out how. Knowing that it is theoretically possible changes everything. It changes how we see ourselves. We are not trapped. We are not prisoners of Earth. We are simply in the cradle. And the cradle is a comfortable place. It is warm. It is safe. But we were not made to stay in the cradle forever. This theory is a promise. It is a promise that if we can survive our adolescence, if we can learn to protect our home and each other, the universe is waiting for us. It is waiting with a patience that spans eons. The Andromeda Galaxy is not going anywhere. The Virgo cluster will be there in 1,000,000 years. The stars will keep burning, the black holes will keep spinning, and the fabric of space-time will keep rippling, waiting for a hand steady enough to shape it. We build the future with our minds first. We build it with mathematics. We build it with stories. We build it with the quiet conviction that the impossible is just a problem we haven't solved yet. So, tonight, when you look up at the sky, look past the stars. Look past the constellations you know. Try to see the darkness between them. Do not see that darkness as a wall. See it as an ocean that is deep and dark and silent, but an ocean that can be sailed. We are the shipbuilders, we are the navigators, and somewhere, in the equations of a physicist or the dream of a child, the first timbers of the ship are being laid. The galaxies are calling, and one day, perhaps a long time from now, but one day, we will answer. Visual direction. The screen remains dark for a moment. Slowly, a new image fades in. It is a composite image of the night sky, but not as we see it. It is a map of the known universe, with millions of galaxies represented as tiny colored dots. The camera pans across this cosmic web, emphasizing the sheer scale of the structure. We have spoken of the possibility of travel. We have spoken of the warp drive and the wormhole, the tools that could unlock the cage of our galaxy. But there is a question that haunts every physicist and dreamer who looks at these equations. It is a shadow that hangs over the entire concept of intergalactic travel. If the laws of physics allow for it, where is everyone else? This is the Fermi paradox. Consider the age of the universe. It is 13.8 billion years old. Our solar system is only 4.5 billion years old. That means there are stars and planets in the Milky Way and in the galaxies beyond that are billions of years older than us. If a civilization arose on just one of those planets, and if they discovered the secrets of the warp drive or the wormhole, they would have had billions of years to spread. Even at slow speeds, without bending space, a civilization could colonize a galaxy in a few million years. With a warp drive, they could do it in a blink of cosmic time. They should be here. They should be everywhere. The universe should be teeming with the noise of their engines, the light of their Dyson spheres, the transit of their wormholes. But when we point our radio telescopes at the sky, we hear only the static of dying stars. When we look for their megastructures, we see only dust and gas. The silence is deafening. And it leads us to uncomfortable possibilities. Perhaps intergalactic travel is harder than the math suggests. Perhaps the energy requirements are truly impossible, not just theoretically daunting. Maybe the speed of light is a wall that can never be cheated, and every civilization is forever trapped on its own island, destined to rise and fall in isolation. Or perhaps there is a great filter. Maybe civilizations like ours, young and aggressive, tend to destroy themselves before they reach the stars. Maybe the transition from burning fossil fuels to harnessing black holes is a test that few survive. The silence of the universe might be a graveyard of species that discovered nuclear power before they discovered wisdom. But there is a more hopeful, albeit stranger, possibility. Imagine a civilization that has mastered the warp drive. They have transcended the need for planets. They live in the curvature of space itself. They have no need to broadcast radio waves. They have no need to conquer. They might be watching us right now, not with malice, but with the quiet observation of a biologist watching bacteria in a petri dish. They are waiting to see if we make it. They are waiting to see if we are worthy of the keys to the car. In this view, the silence is not empty. It is pregnant with waiting. It is a quarantine, and the only way to break the quarantine is to prove that we can travel without destroying the destination. The Alcubierre drive, then, is more than a machine. It is a graduation test. To build it, we must master energy. We must master cooperation. We must master ourselves. If we can do that, perhaps the silence will break. Perhaps, when we finally turn the key in the ignition of our first starship, we will find that the lights turn on all across the galaxy, and we will realize we were never truly alone. Let us cast our minds even further forward. Past the first flight, past the colonization of the Milky Way, past the meeting with other intelligences. let us look at the deep future. The universe is evolving. It is not static. Stars have life cycles. They are born, they fuse hydrogen into helium, and eventually they die. The era of stars, the stelliferous era, will not last forever. In a few trillion years, the last stars will burn out. The galaxies will go dark. The universe will enter the degenerate era, populated by black holes, neutron stars, and cooling white dwarfs. If we are bound to Earth, or even bound to our solar system, our story ends when our sun dies. But if we have the keys to the galaxies, our story can continue almost indefinitely. A civilization that can traverse the intergalactic void is a civilization that can outrun the death of stars. When the lights go out in one galaxy, they can move to another where new stars are still being born. They can become nomads of the cosmos, chasing the energy of the universe as it slowly winds down. With the power to manipulate space-time, we might even do more than just survive. Some theories suggest that a sufficiently advanced civilization could manipulate black holes to harvest energy from their rotation, a process known as the Penrose process. They could huddle around the last dying embers of the universe, living in digital utopias powered by gravity itself for eons after the last star has faded. And there is an even profounder thought. If the universe is destined to end, either in a big freeze where everything cools to absolute zero, or a big rip where space tears itself apart, then the ultimate goal of any intelligent species must be to escape the universe itself. The wormhole equations we discussed earlier offer a tantalizing hint. If a wormhole can connect 2 points in our universe, could it connect our universe to another? Could the Einstein-Rosen bridge be an escape hatch? We are speculating now at the very edge of human comprehension. But the story of humanity has always been about escaping boundaries. We escaped the ocean to live on land. We escaped the gravity of Earth to walk on the moon. We are dreaming of escaping the solar system to reach the stars. Why should the boundary of the universe be any different? Perhaps in the unimaginably distant future, our descendants will not be human in any way we recognize. They will be beings of pure energy and thought, masters of the fabric of reality. And as the curtain falls on this cosmic stage, they will open a door in the darkness and step through to a new beginning. This is the ultimate promise of the theory. It is the promise that life is not a fleeting accident, destined to be erased by time. It is the promise that life is a fundamental part of the universe, capable of understanding it, shaping it, and perhaps transcending it. So, as we close this journey, remember that the equations written on chalkboards today are the seeds of that future. The dream of the warp drive is the dream of eternity. We are small, we are fragile, we are currently stuck on a rock. But in our minds, we possess the map to the infinite. And as long as we keep looking up, as long as we keep asking, what if? The journey never truly ends. Visual direction. The camera pulls back to show the entire observable universe as a single glowing sphere. It pulses once, bright and warm, and then gently fades into a peaceful, absolute black.